All right, guys, Chavez here. This is a tutorial on how to fill out that unit circle quiz, guys, that we've been having all this lately. So here, let's just go right into it, guys, and see what's up. So before you can answer these questions, you got to have a pretty good understanding of the unit circle. Don't be a robot. I mean, I guess you can memorize elements at a time if you want, but don't be a robot, guys. So this should be pretty easy to do. At least I hope. So here's the tutorial. This is 0 degrees. That's where you start. You start on your positive x-axis. And then the difference, x-axis and y-axis are perpendicular to each other. So hopefully that you know that that's 90 degrees. And then add another 90, that's 180. And then add another 90 to 180, that's 270 degrees. And then add another 90 to 270, and that's 360. You've done a whole revolution. And then these are all special angles, guys. They're formulated from your 30, 60, 90 triangle and the 45, 45, 90 triangle. So that means this gap here is always 30 degrees. So these gaps between your axis, those are always 30, right? So I'm just going to show that real quick. So those are always 30, guys. Always. And then intermediate. I can't talk today. That little gap in between there, that's a 15-degree gap, and it holds that pattern everywhere, guys. So I'm going to go ahead and erase all this here. And that way I can have a nice clean circle here. Let's just go by that pattern. So 0 plus 30, that's 30 degrees. And then add 15, so 45. And then add a 15 to that, that's 60. And of course, you add 30 to 60, and there's your 90. And then 90 plus 30, there's your 120. Add 15 to that, that's 135. Add 15 to that, that's 150. And then add 30 to 150, that's 180. 180 plus 30, that's 210. 210 plus 15, that's 225. 225 plus another 15, that's 240. And then 240 plus 30, that's your 270. 270 plus 30, there's your 300. 300 plus 15, there's your 315. And then 315 plus 15, that's another 3, there's your 330. And then 330 plus 30, there's your 360. So that's how you can verify you did it right. And now it's time for the radians. We should at least know these. 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and then 1 full revolution is 2 pi. You should at least know those, right? So 1 revolution in degrees is 360 degrees, and 1 revolution in radians is 2 pi radians. So from that, half of 360 is 180, and half of 2 pi is pi. So this is what we use for conversions, either 180 over pi or pi over 180. So if I want to go from degrees to radians, you could, if you wanted to, go 30 degrees times pi over 180 degrees. And sure enough, 3 goes into 18 6 times. So that's pi over 6. So this guy's pi over 6. And you can do that over and over again if you wanted to. 45 degrees times pi over 180 to get your radians, right? 45 goes into 90 twice. So 45 goes into 184 times. So that's pi over 4. And you could do that over and over. But there is a pattern, a very obvious pattern to this, guys. That's what I hope to showcase in a little bit. Okay, and I know you could have gotten that pi over 3 by doing pi over 6 plus pi over 6, which is 2 pi over 6, which reduces to pi over 3. But it's the same deal, guys. So put a 3 down here, and the numerator is going to be 2 pi. And then for that denominator, keep the pattern the same. That's a 4, and it's going to be a 3 pi. And then this is going to be a 6, and it's going to be a 5 pi. And in case you're wondering how we got this pattern, guys, well, it's just the same thing as last time with degrees, but this time with radians. This dude right here, that's pi over 6, and that's pi over 6 everywhere. All of those, right? All that's pi over 6, pi over 6. That's pi over 6. The distance, or the rotational distance there, that's how much it's 30 degrees, right, between the axis and the next angle, the special angle. Excuse me. So imagine, if I were to do this one in black here, that's pi radians right there if you rotate that much. So notice this in red, that's pi over 6 away. So 5 pi over 6, so you're pi over 6 away from pi. If I were to take that 5 pi over 6 and add pi over 6 to it, notice you get 6 pi over 6, which is pi. And OMG, well, that's pi. You have to get pi, right? So that's just something to observe, guys. It's not something extreme. But because of that, we have these patterns. So if you were to rotate from the x-axis here all the way to there, this is pi over 6 away from doing a whole revolution. Remember, a whole revolution is 2 pi. So this guy must be 11 pi over 6. See? Because 11 pi over 6 plus pi over 6, that gets me to 12 pi over 6, which is 2 pi. See? So hopefully that makes sense, guys. And because of that, we have this pattern. So I'm just going to add pi over 6 to pi, and you're going to get 7 pi over 6. See? Like that. You add pi over 4 to pi, and you're going to get 5 pi over 4. See? You add, sorry, I didn't do it perfect there, but that's pi over 3. You add pi over 3 to pi, and that's 4 pi over 3. See? So nothing crazy, guys. It's pretty straightforward. So what happened on quadrant 2? The integer is 1 less. So see, then the denominator. The denominator is 3, so 2 pi over 3. The denominator is 4, so 3 pi over 4. The denominator is 6, so 5 pi over 6. In quadrant 3, the numerator is the integer in front of the pi is 1 more than the 6 than the denominator. That's a 6, so 7. That's a 4, so 5 pi. That's a 3, so 4 pi. So there it is, 7 pi over 6, 5 pi over 4, 4 pi over 3. And I got to be careful. I really shouldn't be saying integer because it's tied with that pi there. But I'm just talking about the coefficient in front of the pi, if I may. So yeah. So again, how did we do this? Well, you got to keep the denominator. That's a 3. Double the denominator. 3 times 2 is 6. Chop. Why are you doubling the denominator? Because 6 pi over 3 is 2 pi. And then subtract 1. 5 pi. See? Double the denominator. That's a 4. So double of 4 is 8. And subtract 1. So 7 pi. Double of 6, that's 12, and subtract 1, that's 11 pi. And there it is. And then, of course, the radius of a unit circle is 1, guys. So we should know that's 1, 0, 0, 1, negative 1, 0, 0, negative 1, and there it is. And, of course, you get these angles from your special right triangles, right? This one's a 30, 60, 90 triangle, so your short leg is a half, and then your long leg is a half times square root of 3, which is going to go over here. That's a 3 there. So there it is. And then the same thing with this. The radius is 1, so divided by square root of 2. 1 over square root of 2 will get you the legs. So you can write 1 over square root of 2. But 1 over square root of 2, when you multiply by square root of 2 over square root of 2, you get square root of 2 over 2. In case you're wondering, Chop, I have no idea what you're talking about. I'm talking about the 30, 60, 90 and the 45, 45, 90 triangle. N square root of 3, 2n. This is my relationship. My hypotenuse is a 1. So if 2n equals 1, that means n equals a half. So my short leg is a half, and then my long leg is a half times the square root of 3, which a lot of people write it as square root of 3 over 2. See? So there it is, guys. So hopefully that all made sense to you guys. And here's the pattern. Please don't, you can memorize them, but please make sure that you're not a robot and you know where these values come from, guys. Please, please, please. I am kind of going through it kind of fast, only because I ordered pizza, and I don't know if the pizza delivery person is going to get here before I finish this video. So yeah. Let's continue the pattern reflected across the y-axis here for quadrant 2. The x value is negative now in quadrant 2, so negative a half, square root of 3 over 2, negative square root of 2 over 2, square root of 2 over 2, and then this one's negative square root of 3 over 2, 1 half. And then in quadrant 3, both of them are negative, so negative square root of 3 over 2, negative 1 half, negative square root of 2 over 2, negative square root of 2 over 2, and then negative 1 half, negative square root of 3 over 2. And then just reflected, the x is positive now, but the y is negative. So 1 half, negative square root of 3 over 2, square root of 2 over 2, negative square root of 2 over 2, and square root of 3 over 2, and negative 1 half. So you got to know the unit circle before you can tackle these guys. All right, so now what? How do I do this? So secant the reciprocal of cosine. So, Chop, what does that even mean? It means this, 1 over cosine. That's what it means. It's reciprocal cosine. So pi over 3. So I'm going to write cosine of pi over 3. Let's see what that would have been. I come over here, remember? Okay, real quick, really fast. Theta, and I'm going to write my horizontal displacement is x, my vertical displacement is y. This corner there, that's x comma y. SOHCAHTOA. So sine of this angle is opposite over hypotenuse. If the hypotenuse is 1, that's just going to be y. Cosine of this angle is adjacent over hypotenuse. So adjacent is x. Adjacent just means next door, right? And the hypotenuse already has a name. That's that long leg there, or the longest side of a right triangle. It's always going to be that. You can also say a squared plus b squared equals c squared, and that's your c there. So yeah, so there, my cosine is going to be x adjacent over hypotenuse. X divided by 1 is just x. So there it is. And then tan is just y over x. And then your reciprocals. Secant is 1 over cosine. This is not a lesson, guys. This is just going over the unit circle. So again, cosine of pi over 3, I go to pi over 3. So let me go to pi over 3. And cosine of pi over 3 is a half. So I write 1/2. But notice it says secant is 1 over cosine. So that means secant of pi over 3 is 1 over 1/2. Keep, change, flip, or how many halves go into a 1? 2. So the easy trick, just take the reciprocal, guys. That's what it means, 1 over cosine theta. That's why we call these the reciprocal, secant, reciprocal, cosine. So yeah, let's do it. Cosine of 7 pi over 4. 7 pi over 4, there it is in quadrant 4. Cosine's the x, so square root of 2 over 2. Okay, and then tangent of 2 pi over 3, y divided by x. So I go to 2 pi over 3, and y divided by x. So my y value is square root of 3 over 2 divided by my x, negative 1/2. So negative square root of 3. Okay, so now how do you tackle it without looking all the time back? Here's how you do it, guys. So I look at this and I say sine of 7 pi over 6, and I think sine is the y value, and 7 pi over 6 is in quadrant 3. So it's on all the pi over 6's, so I guess I'll write it like this. What's sine of pi over 6? Sine of pi over 6 is a half. And then I'm going to go ahead and put the 1 in quadrant 2. Sine of 5 pi over 6. Sine of 5 pi over 6 is a half. See, because I'm in quadrant 2 for 5 pi over 6, so the y value in quadrant 2 is positive. Sine of 7 pi over 6, that's the one I have here. That's in quadrant 3. It's going to be a negative half. See? You just got to think about it. And then the same thing, sine of 11 pi over 6, that's also a negative half. So you just got to think about it, guys. It doesn't even require that much thought. You just got to put a little bit of thought. So 5 pi over 3. So let's see. Double the denominator, 3, 6, subtract 1. So that's quadrant 4. Cosecant is a reciprocal of sine. So sine of 5 pi over 3 is a negative square root of 3 over 2. But so this is going to be a negative 2 over square root of 3. Just flip it. Or you can also say negative 2 square root of 3 over 3. They're both the same if you rationalize it. Sine of 11 pi over 6, negative 1/2. See? That's it. You just think about the y value. You're in quadrant 4. And sine of all the pi over 6 is a half, but you're in quadrant 4, so the y value is negative. Cotangent of 5 pi over 6. Cotangent is x divided by y because tangent is y divided by x, and the reciprocal of y over x is x over y. So at 5 pi over 6, you're in quadrant 2, and quadrant 2, 5 pi over 6 is square root of 3 over 2, negative square root of 3 over 2, comma half. So I'm going to write negative square root of 3 over 2 over 1/2. So this gives me negative square root of 3. See? Cosine of 4 pi over 3. So 4 pi over 3 is in quadrant 3 because I see that this is a 4. It's 1 more than 3. Of course, it's 4 pi, right? 4 pi over 3. So then I think, and I'm like, oh, okay, that must be a negative 1/2. And then because all the pi over 3s is going to be a half for cosine, you just got to think whether it's positive or negative. Sine of pi over 6, that's a y value. At pi over 6, that's going to be a half. See, it's right here. Sine of 3 pi over 4, that's a y value. I'm in quadrant 2. The y value in quadrant 2 is positive, so square root of 2 over 2. Tan of 5 pi over 6, y divided by x. At 5 pi over 6, the coordinate is negative square root of 3 over 2, comma 1/2, guys. So 1/2 divided by a negative square root of 3 over 2, which is the same thing as a negative 1 over square root of 3. And the best answer for this, obviously, is negative square root of 3 over 3. So this is the best answer, but all three of those are equivalent. Sine of 5 pi over 6, quadrant 2, that's going to be a 1/2 again. See, just like the one up above. Secant of 2 pi over 3. So you think about cosine. Cosine at 2 pi over 3 is negative 1/2. So it's going to be a negative 2. See? Cosecant of 4 pi over 3. At 4 pi over 3, that's quadrant 3, guys. And 4 pi over 3, you're going to have a negative 1/2, negative square root of 3 over 2. This is the reciprocal of sine. So a negative 2 over square root of 3 or negative 2 square root of 3 over 3. Both are the same. Well, okay. Yeah, that's it. Cosecant, there it is. And then finally, cotangent of pi over 2. Cotangent is x over y. At pi over 2, you're up here. That is 0, comma 1. So 0 divided by 1, which is equivalent to 0. All right, guys. If you felt that I went through that kind of fast, I did. It's because I'm waiting. I don't know if the pizza dude is gonna be here any moment now. But give it a thumbs up if that helped. And if you want me to make some more short videos like this, let me know. All right. Talk to you guys later. Bye-bye.